recap what we did yesterday, if we learn how to simplify non-perfect square roots. Why do we care? Well, sometimes they show up in our quadratic formula problem, and this week, whether I have you for algebra or not, you're probably learning about the quadratic formula. So, when you have a non-perfect square, you do have to simplify it. You can tell if you need to simplify it by breaking it down to its prime factors, so make a factor tree. Looking at only the prime numbers, we look for pairs if it's a square root. And then if it is a pair, for each pair you write it once outside the radical. So what have I been telling you to imagine this radical is? Like a jail cell. So if you have a partner, you can escape the jail. If you don't, then you are stuck inside. Now, if there's multiple numbers on either side, so maybe you have multiple pairs, multiple left over, you multiply them together. So like that's why in example 10, it was 3 times 2 on the inside to get 6. In example 11, we had 2 pairs of 2's on the outside. So we multiply them together to get 4 and so forth. Questions on that? All right, I think it's easy. Probably one of my favorite lessons all year, but if you are so confused, you can try another one. So say the number is, let's look at 9. Well, 19 probably doesn't help. Let's look at number 18. So now a larger number. All numbers that end in 3 are divisible by what? Well, I wouldn't say all numbers, but what do we think this number is divisible by? Probably. Someone said 4, I think. So 343 divided by 4 is not perfect. What else do you think it might be divisible by? 7, probably do not. Well, let's try it. Oh, it actually did work. So 343 divided by 7 is 49. So those could be 2 numbers that multiply to 343. Is 7 prime? Okay, so that one's broken down already. Is 49 prime? What goes into 49? All right. Now look at only your prime numbers. So don't look at the 49 or the 343 because that's what we were simplifying. Do I have any pairs of the same number? How many? I have 1 pair of 7s. That will be written on the outside of the radical or the jail, whatever you want to call it. Just once for each pair, you write it. Do I have any left over? I have this 7 left over, it goes in the jail. So for 18, it's 7, radical 7 is how you read that. Questions? Okay, 19, I'm pretty sure that number is prime. I can't think of anything that multiplies to 117, can you? Okay, I can't either. I'm pretty sure that number is prime. So in that case, if it's not factorable, then you just leave it as is. I'll definitely look it up and see for sure. Chris, did you find it or? $39 times what? Okay. So yeah, probably should check first, but I don't have my answer key on me. But yeah, so if it is divisible by something, do simplify it. I know like I have seen on the tests, sometimes the numbers just aren't able to be simplified because they're prime, and then you just leave it as is. But yeah, that does work. 39 times 3 does multiply to 117. You can keep breaking it down. Like 3 times 13 gives me 39. And then what would my radical be for number 19? 3 radical 13. Good. This time I didn't show all my work, but don't look at the non-prime numbers. Have a pair of 3's there and a leftover 13. So no partner, you don't get to escape. Good? Okay. Now the cube roots are, I would say,
not essential for unit 7, but it is good to know that if you have a cube root, you can still simplify it. It's just instead of looking for pairs, what do you think I'm going to look for in the cube roots? Not singles. Triples, yeah. I'm going to look for 3 of the same number because in order to escape, it's kind of like that's a little rule or something. That's my rule. I need to have 3 now to escape. For the square root, the little number is usually not written, but it's 2. That little number, the index. So that's why for that one, the rule is 2. Okay, so these are going to be more like practice. We don't need to know the first 10 perfect cube roots. I don't think that's essential. But in your calculator, you can, all scientific calculators have a button where you can put in a number for the index. On Desmos, you could press functions, scroll all the way down, and this is the button. Scroll all the way down, it has like an N and a square root symbol. And then it lets you type in. So if I want to find the cube root of 8, I know that that's 2. So 2 cubed is 8, so the cube root of 8 is going to be 2. And then you could see if it's a perfect cube root if by honestly just typing it in. So like 729, that cube root is 9. Because 9 times 9 times 9 is 729. Questions on that? Now, is it possible to take the square root of a negative number? Was that a yes or a no? Mm-hmm. You cannot. You cannot take the square root of a negative number. I'll even show you right now. All right, I can't take the square root of any negative number because it just says undefined, right? Because I could never square a number and get a negative. That's impossible. Do you think I could do a cube root of a negative number? Yes, you actually can. So like in 25 on your note sheet, that example is the cube root of -1. It is possible to do -1 times -1 times -1. That's -1 cubed. And get a negative answer. Because you just need an odd number of negatives. So if you're told to take the cube root of a negative, just know like your answer should be negative. Same thing. So perfect ones, perfect cube roots, you get integers. So like cube root of 343 is -7. Questions on that? Okay. So then if it's a non-perfect cube root, like these numbers down here, you can't cube really any number to get those. You still need to simplify them. And you do it the same way. Again, it's just now we're going to look for triples. So what's a pair of numbers that multiplies to 40? 10 and 4. Are they both prime? No, they both can be broken down further. So what multiplies to 10? Are those both prime? Yes, so we're good there. What does 4 break into? Now, am I looking for pairs in this one? In this one, I am not, because this one, the rule is 3. So the little number that's written here for square roots of 2 is usually not written for square roots. But in this one, it's a cube root. So I'm looking for 3 of the same number. Do I have that here? Yes. I have 3 2s. So for each set, write it once and put it where? Outside the radical. Don't forget this is a cube root, so you need to show that. So 2 cube root 5. So we still have a leftover number. These 2 were not prime, so we're not putting those in our radical. But there.
Really, I'm only showing you this part so that you can do the practice. All right, which other one do you want to see in here? In this set? Someone's difficult. $32, you said? Okay, let's look at 32. Since that number ends in 2, I know that 2 times something gives me 432, so I'm gonna figure that out. All right, I got 216. Times 2 gives me 432. I'm sure there's other bigger numbers, but that's all I have to think of. 2 is prime, 216 is not. I know because it ends in an even number, so I know that 2 times something 108 gives me 216. It is 108 prime. No, because it ends again in an even number, so I know it can be broken down into 2 and 54. Is 54 prime? What does 54 break into? Is it, I'm losing my mind right now. Yes, 9 and 6, okay. And then still both of those are not prime. What does 9 break into? 3 and 6 breaks into. Very good. So kind of a big one. But as long as at the end of each branch you have your prime numbers, then you're good. I'm going to cross out the non-prime numbers just so we're not confused. Only looking at the prime numbers, do I have any triples? What are a triple of what? Anything else? And 2s. Don't know how to really make a nice circle, but triple of 2s there, right? And then I have 1, 2 that is left over. So now you have to know like where they go. So where does the leftover 2 go? In the jail, because it didn't have a partner, or like for this one you need 2 partners in addition to yourself, so that one stays inside. What do I do if I have a triple of 2s and a triple of 3s? Multiply them. What's 2 times 3? So it goes 6 cube root 2 for that one. So that was a good one to go over. It was a little more challenging, but still same concept. Good. All right, just so we could do a negative example, what multiplies to 16? And 4 breaks into. All right, let's see. Do I have any triples of the same number? 1 triple of 2s, and then a leftover 2. So don't worry about the 4s, those don't count anymore because they're not prime. So what goes in the radical and what goes outside the radical? But since my answer is negative, I'm just going to put the negative on at the end. All right, so if your cube root is negative, then just put the negative on the one that escaped. That makes sense? Okay, really just so you can do the practice. I'm majorly focused on you guys understanding how to simplify a non-perfect square root. Okay, so this practice, this was what you were, if you had me for algebra, this is what you were supposed to do Thursday, but I don't think everyone did, or maybe they didn't know how, or maybe they actually cheated. Regardless, I taught you now how to do it. So evens or odds, your choice. If you already have it done, great. Then you have some time to work on, say, like the study guide for Unit 7, or your practice constructed response for Unit 7, or your puzzle pieces for Unit 7.
But evens or odds, I won't give you the rest of the time, because I think that would be excessively long. Probably start with like 25 minutes or so and then check in. Questions, daily? Yes. Mhm.